All right, so let us continue. And we already have the discussion for scheduling in the first class. And later we will have the network neutrality. And then we go to a different discussion talking about the Internet Protocol, IP. So after now, it goes through maybe slowly. But this after now, it seems to be understood well, so that's good. And yes, let me get back to the discussion. Okay, so it's good, and let me continue. And we will switch from the previous discussion talking about the switching fabrics. To the new one. In fact, we finished discussion for what's inside a router. Specifically, we talk about switching fabrics. And for the switching fabrics, actually, we have some possible management, including scheduling. And right now, let us focus on, in fact, it should be the focus of the current chapter, IP, the Internet Protocol. For IP, of course, we already have the format and addressing. Specifically addressing, it should be the focus of our discussion. So, network layer. In the previous chapter, we already have the transport layer. And in fact, we already have the IP and socket port, so IP and port number. And so that we have the way to identify a socket or not. And yes, right now, we formally discussed the network layer, Internet Protocol. Within the Internet Protocol, of course, we can have the routing algorithm. Up to now, we don't touch it. And actually, we have a specific one, IP. Here, IP. So we have an IP protocol. And currently, we focus on IP protocol. Of course, IP protocol, we have the format, we have addressing, and the important one should be packet handling. All right, so important one should be the packet handling. How we transfer packet from maybe one device to the next device, the network layer devices. Of course, corresponding to IP, we have ICMP. MP actually corresponding to the control management protocol. Therefore, we have the error reporting. Of course, we have the router signaling. Well, we have IP, and associated with IP, we will have ICMP. And after the two protocols, then we will focus on the specific one. It's the routing protocol, but let us have an IP protocol first. This is a format. Of course, you can go through the individual fields quickly. And right now, we have the way to explain. First one, version. I think it's okay, right? Second one, it's the length in bytes. And we have the field type of service, which type of service. And we have the total datagram length, likewise in bytes. Previous one is header. Current one is the total datagram length. And here we have the maximum size. So maximum, it should be 64K. And the typical one should be 1,100 bytes or less. And previously, we already have the different service. So different service can be diffserv. We have the possible way to denote from 0 to 5 bits. And ECN or not, we have 2 bits. And TTL, all right, I think TTL, it is the remaining max hops. And upper layer, of course, it can be TCP or UDP. And here we have fragmentation. And after the chapter, we will have the detailed discussion about the fragmentation. But previously, we didn't have the fragmentation. Look at this. We have ID first. All right, so we have a 16-bit ID first. And after that one, we have flags. And flag to have some indication. This is the first one, or we have the following one. So we have a flag. We have 3 bits associated with flags. And so that we have fragment offset. Offset says, okay, we have this one. We should know where we have the next segment. So we have the offset. Also, the calculation of the offset, we will have the detailed discussion. But first of all, notice here, we have 3 bits associated with the flags. Because of the 3 bits, then we will have the different way to have the offset calculation. And later we will let you know, because of 2 raised power to 3, we should have 8. We allow the offset over 8 because of the length consideration. 我现在先用中文讲一下哈，我们这个3个 bits 的栏位是 flag， 因为这3的 bits 是2的30方等于8，所以我们的 offset 其实要除以8，除以8不是因为 byte。 Alright, so because of the 3 bits for the flag, and we have the calculation for the offset to over 8 because of the size for the offset rather than to have the count in bytes. No, I will let you know that one later, but initially I didn't have this. Specifically, I didn't have a big discussion in Chinese to let you know directly. All right, so we have IP, source IP, and destination IP. And of course, we have the optional one. However, you can count, we have 20 bytes. Likewise, 20 bytes at this. Therefore, we have, for example, you can check UDP. At this for TCP, we have 20 bytes header. And if we count the header for the whole message, 20 for TCP and 20 at this for IP. And so that at this we have 40 bytes of 40 bytes plus the app. And so that we have the overheads for sure. So that is the format. And the next one, we want to talk about the addressing. That says how we have the address, and the address to denote a different subnet. So later we will pass on addressing to have the subnet. IP address. So we have a 32-bit ID that says IP. And here we have a 32. 32 because of the previous format, so we have a 32. And the IP address actually will associate with the host router. And so that we will have the so-called interface. And interface or host, or even within the host, we have a different interface. So IP should associate with the interface. All right, so here we emphasize its interface. All right, interface. Therefore, if we talk about IP, actually we talk about the interface. So it doesn't mean we have a host. So we just have an IP. No. for you. You understand? Maybe you have many IPs there because of multiple interfaces. That's why this one. Router typically have multiple interfaces. So we have multiple IPs for the routers. And the host, same. But host, normally we have, at least we have 1. And possibly we have 2. And up to now, maybe you think we can have the enhancement. So maybe more than 2. It's possible. At least for the router, we should have the routing. So of course, we should have multiple interface for sure. And let us have this one, 32. 32-bit IP, and we have 8 bits to have 1 decimal, 1 decimal, 1 decimal, 1 decimal. So that, for example, here we can have 223, 1 and 1 and 1. So something like this. But later we want to have the way to show the IP using binary. So you should have the number changing from a decimal to a binary. So how to do that? I think you should know how to do that, because we will have the calculation based on the transformation. So I see no problem for that transformation. And currently we have an interface. So you see, about the IP, same. In fact, no, not the same, right? And here we already have one question. How are interfaces actually connected? Connected, right? So we have some possible line. Or maybe we have some media allow you to have the interconnection. For example, Wi-Fi. Wi-Fi, then we will have the L connection. And at least we have this so that we have the connection. And of course, possibly it should be wired or wireless connection. So at least we should have a line to connect the 2 interfaces. Or maybe it's an L interface to have the connection. So you see, Ethernet is wired, and the Wi-Fi is wireless. All right, so I think you know this. I think no problem. So for now, it says don't worry. It can be connected, and even we will discuss how we achieve the connection between the 2 interfaces. Yes, we can achieve it, and don't worry. So you see, don't worry. And in fact, even we can have the connection and without intervening router. It says, yes, we can have the connection. Even we will go through the intervening router. But yes, we have the router. But currently, we just ask you, okay, forget it. Yes, we will have the connection for you and for the receiver side. But don't forget, we have the intervening routers. What that means, intervening router, of course, we have the router in between the 2 hosts. So we have the router for sure. Don't forget that one. Even initially we think, okay, forget that one. You can have the connection between the interface for your host and the interface for the host you want to connect. Well, subnets. Subnet, what it means? What's a subnet? Well, check the definition for 1 minute for yourself. I read it for you. Device interface that can physically reach other without passing through. You see, passing through an intervening router. We have the color in red. Oh, that says we have the subnet here without going through a router. So that one serving as the subnet. About the definition, it should be okay for you, right? And here, this is subnet. And here, this is subnet. And here, this is subnet. So, how to have the subnet? One recipe should be 一个方法 detach the router, then you will have some isolated islands. Isolated islands serving as a subnet. 你把那个 router 把它给去掉之后，剩下的孤岛就是所谓的子网路。So how to have a subnet? You can detach the router, and so that you have the isolated nets. Those isolated nets serving us the subnets. Well, because of subnet, then we will have the possible address to include subnet part, to include host part. We will have higher bits to stand for the subnet, and the lower bits and the remaining bits to stand for the host part. And here, this is a recipe. Recipe means this. I'll show you recipe first. This one. Okay, from cooking, we have a recipe. But right now, it's a recipe to find the subnets. All right, so I think I didn't know to detach the router. And so that you have a subnet 1, 2, and 3. So this is a way. Isolating network, then we have the subnet. Well, if we have an example, actually we have many, maybe not many. We have 3 routers, and you can count how many subnets here. It should be 6, right? Yeah, so this is a way to count how many subnets if we can apply our recipe. So it says if we don't have example, how many? It should be 6. And currently we have the subnet with the numbering. We have 24 to denote the highest 24. And because of 32, then we have 8 host paths. So we will use the most significant 24 to denote the subnets. For the remaining, we have the 8 bits for the host paths. Host path, so that you have the degree of freedom within the subnet, right? So only 8 bits to have the different number within the subnet. Well, actually we have 32 and we have S to denote subnet. And normally we expect to have 8 bits and to have 8 bits to serve as a multiple. But just multiple of 8? No. We allow 20, for example, 23. Not a multiple of 8. If so, then we have the specific name CIDR, classless interdomain routing, CIDR address. So you can have S not equal to a multiple of 8. Yes, I emphasize 23 cannot divide it? No. Not divided by 8. It's still okay. So it's called the CIDR address. All right. And so that we have 9 host paths. Oh, sorry, not 9. Oh, okay, it's 9, sorry. So we have 9 9 for the host path. And currently, we already have an example. And in fact, you can think about, is it true? IP address, how you can have an IP address. All right, so the first question, how does a host get an IP address from a network? And second one, for itself. The first one, actually, how we have a subnet. And second one, how we have our for itself. So, sorry, I have the different one. How we have the host itself, how we have the network address. So it says, okay, we should define the subnet, and also we should have our, and so that we know the truth. So actually, to have an address, actually you should have the two different meaning. Your address, so that you have the detailed address from the subnet plus the host part. And at this, you should have a subnet. So we have the two different meanings. For yourself, you can have hard-coded by the system administration. And using Unix, you can have the setting hard copy IP there. Also, you can have the dynamic one, so DHCP later we will discuss. DHCP allow you to have an IP address so that it doesn't mean you have the hard-coded IP address. We already have an IP address, but it's a dynamic IP. So this is the IP addresses to answer the first question. But the second question, you don't have the answer because we will have the setting by, for example, by the country, by the school. And we talk about DHCP further. DHCP, in fact, it doesn't mean you need to have a hard-coded IP within the host, but how we can achieve it. Here, we have the protocol for DHCP. It's a protocol. All right, so you can use it or you can drop it, so you can renew. Or you can have a reuse. So you see, you can renew. You can reuse. And so that it's easy to support mobile user to join a network easily. So we highly support the usage of DHCP because of the convenience. And later, we already have the way to enable the DHCP working mechanism. We should have discovered the current DHCP. And if I am the DHCP provider, I will already have the offer. Yes, I'm here. And you will ask formally, let me have one IP. And then finally, DHCP will already have an ACK. So finally, discover. And I'm here. So this is the first one. And I want to have one IP. And here you are, something like this. So this is a scenario. All right, so the scenario for one subnet, and so that this subnet, we have the DHCP server, and the DHCP server allow, for example, mobile hosts to get one IP. Currently, we talk about IP address directly, rather than, okay, how to determine the subnet part. So we will have a server, and the server co-located with the router, and so that it can provide the IP address directly. And once we have an arriving client need to have an IP address, then based on the DHCP protocol, it can have one IP. Well, we based on the previous 4 possible messages, and so that we have the message exchange between the server and also the client. So first of all, we send this because right now we don't have the messages. So we have the broadcast. Broadcast, we will have the broadcast IP. All right. So it says, okay, because I don't have an IP, is there DHCP server here? So source address. Up to now, we have the destination. It should be broadcast. Broadcast using 255. So we have a 4. This is a broadcast address. So broadcast IP. And currently for source IP, it's a blank. It's a blank, so I have all zeros. And we have a port number. So up to now, maybe you think why we have the setting for those port number. I think skip them. And at least we have a broadcast. And why address? So yield address, no, currently no. And the transaction ID is an ID for DHCP. Someone like, okay, we have an interaction. The current ID, maybe no specific reason. We just have, for example, 654. For some reason, maybe we can assign their ID for DHCP protocol. And so that we have a response from the server. I'm here to that I have the IP later. So source, actually we can see this is the IP for the DHCP server. And destination, same, we have a broadcast. But currently we can contain still the same, the transaction. We have a lifetime. Why we want to set lifetime? We expect to have the setting within the time period. So we have the lifetime. And right now, specifically, we want to ask. You see, I also mentioned this one. Yeah, in fact, we already have the year IP, but currently you don't have the request. So even you see it, but you still need to go through the following request message. So up to now, still empty. All right, still empty. But we have something within this, so we still include this. Or maybe you don't think so. Perhaps it's empty here or it's all empty. That's fine. But currently, we let see, oh yes, later we will have a yield ID, Y-I-E-L-D, yield ID, IP. So yes, this is a formal setting. I already have the year IP. So IP address 223.1.2.4. This is the IP address for you. All right, so this is the fastest for the DHCP server. Based on the previous 4 possible message type, then we can get one IP for the current arriving host. So this is DHCP. That you have 1 minute to discuss with your neighbor and think about this. So about DHCP, it should be okay for you, right? All right, so I assume everything's okay with the DHCP. With the DHCP, at least we can get an IP address for the host. Are there any possible functions for DHCP? The answer is yes, more than an IP address. So data check. what possible function does DHCP have? So DHCP, of course, can return the IP address. That's okay. And also DHCP can return this one, address of the first hop router, and DNS server, and network mask. So, in fact, DHCP can bring these, these along with the IP address. So this is a possible example. We have the coming host. And so that we have a DHCP protocol. And DHCP protocol actually is an app protocol. So above UDP, think about why we want to use UDP. Because something like this is a network management issue. So we use UDP. We don't care about you have it or not. So we choose UDP. So this is the protocol stack if we have a UDP. So send it to the router. And so that we return the information to the host. And including O. All right, so here we just want to let it know, yes, through the communication, we include all the information to the host, and so that the host indeed to get O. All right, that's it. I go through quickly and let it know, yes, we have O. And up to now, we already have the IP address, maybe using DHCP directly. However, maybe you have a reason. Why, for example, NTUST should have an IP, it should be, recently I forgot the IP. 我们的 IP address 是 140.11 多少 118 It should be 140.118, right? Maybe you have a question why NTUST should have the subnet mask like that. Of course, it should be determined by some administrator. For example, for Taiwan, we have the administrator. It should be the education to allocate IP address to NTUST to the other schools, to the other university. But at least, maybe for some reason, we will have the allocation. And we don't know the policy, but at least later we should have the possible way to have the allocation. Even we don't care about the policy. So let us care about the ISP address block. 20 actually is CIDR address. And in fact, we based on binary. I emphasize this specifically binary. It's a binary, right? It's a binary. We have 20, so 20 you can count. Okay, maybe for some reason, the ISP with an address block to this. And right now we want to have a division to 8 blocks. 8 blocks coming from this. So 8, because of 8, so we have 3 bits. Because of the current address block to divide to have further 8 subnets. So we should include 20 plus 3, so we have 23. So right now we have 23. So the current idea, I think it should be straightforward, right? Initial subnet, we have /20. And assume you are the administrator and you want to divide the IP addresses into 3 blocks. So, sorry, 8. 8 blocks, so you should have 3 bits, 3 more bits, 3 more bits, so you have 20 plus 3. So you have 23 for the subnet mask for the individual organization because of the newly divided A blocks. About the current idea, it should be okay, right? And right now, we already have one idea. And this example also explains why we should have longest prefix matching, right? Previously, you already have the longest prefix matching. And we can use the current example to let you know why we should enable longest prefix matching. Because right now, this is a normal organization. To have organize 0 to organize 7 based on the previous setting. All right, that's fine. And we have something like, okay, we have a name. Fly by night, ISP. All right, I'm not sure why we want to have a name like this, but it's a flying by night ISP. All right, so normally this ISP accept, you see, 20 subnet within the fly by night ISP. It says we have a broadcasting to have an advertisement. All right, all the IP address follow this phone, then direct to me. All right, direct to me. So this is the previous story in the previous page, but we have the next one. We have the exception. The exception here. So, the story changed. Organization 1 wants to move from fly-by-night ISP to this one. Right? So currently you can see the story. Organization 1 moved totally. Someone like, okay, I sell the address block to the ISP S-R-use. So right now we have this one. So you should have the specific mention. The IP address with this kind of a block, subnet for this one, /23, and also mention that one. Mention that one. So this one longest. Oh, this one longest. If we care about the current IP address for organization 1, of course, the organization 1 prefix longer than the broadcast by fly-by-night ISP. Right? So we choose, okay, I trust you. So I direct the IP address of organization 1 to the current one, ISP-R-U. 那我还是用中文讲一下。原来本来1是在20那一个领域，现在1离开了有23，所以20跟23谁比较长？当然是23的这个特定的这个样子，所以它就会送到这边来，不会送回去给他。So this one can explain why we use the longest prefix matching can work if indeed we can sell the IP block to the other ISP. So that's okay, that's fine. So finally, this one, yes, I have the advertisement. My IP address, for this IP address based on the prefix matching, please forward the address with this block to ISP-R-U. If I claim this, it will have a conflict with the previous organization? No. The previous fly-by-night ISP even claim we have addresses /20. However, we have the exceptional one claimed by the later one. The later one can still have the address and receive the packet with this address. And so that this one can work properly because of longest prefix matching. That's it. So that says even you can have the block division, we still can sell part of the blocks to the other ISP. So that's fine because it can work with the longest prefix matching. So we have the discussion, you see, if yes, we have addressed because of this one, organization one. Why? Because of this one, because of the longest prefix matching. This one actually because of longest prefix matching. So, I already have the remaining one. Yeah, I know we can have all of those, but which organization to take care of this one? ICN. All right, ICN then assign you an IP, and also ICN that they have the name, and that's it. So I already have the information about this. And actually, for IP address 32, it should be IPv4. However, how about longer one? We should have the extension IPv6. And then we have 128. And currently, even we still use based on IPv4. In fact, it should be okay. But in the past, some of our researchers think we should have a longer IP. So that's why we should have IPv6. And later we will have the further discussion about IPv6. But let me stop here. And we talk about IP formally in the second class. And actually, yes, we finish it to discuss how we have the allocation of IP address and the subnet. All right, that's all. This is the discussion in the second class. And before you go, Sam, let me make sure any questions? If not, that's it. We talk about IP in the second one. And if no further question, see you. Bye-bye.